Hey guys, welcome back to another video guys. Today's video we are going to be having a look at a very challenging topic, and I think it's one of the hardest topics for me, according to me, in this syllabus, and that is organic chemistry. So we're going to do this topic in baby steps. Okay, we're going to first learn how to draw these structures, because that is one of the most common questions that come up usually from time to time from these past papers. They ask you about just two things in organic chemistry. First of all the factors and the reactions that come with these organic chemistries. Like, you need to know about alkenes reaction with bromine water, you know how to show that it's double bonds, so on and so forth. And the second vital part is something called the structures, and in today's video we will be dealing with this second one, structures. Okay, I started, let's start off with structures, right? Let's first of all learn how to draw each of the following, right? Each of the following, and then work our way up there. Because the thing is, with this factors and reactions, you have notes, you just revise them. Okay, there's nothing a lot to explain. You have to cram them. For this topic right here, you got to cram. Okay, you have to cram the different reactions, the different temperatures, so on and so forth. I cannot help you with that. But what I can help you with is the structures. I'm going to teach you how to draw any structure. Now, we have different types of structures again. We have these normal alkane, carboxylic acid, alcohol type of structures. And then we have structures like esters. Now, structures like esters will be for another video, because you need to understand the reason behind why we do esters, what is esters, which two groups make esters, which is carboxylic acids and alcohols. Just a quick, if you want to just quickly go over that. But esters is for another topic, it's another video. Okay, today's video we're simply just going to be having a look at structures. If the past paper question tells you draw alkanes, how are you going to do that? Okay, that is what we're going to be having a look at in this video. If they tell you how do you draw propane, okay, what is the steps for you to draw propane? Such a simple question can carry many marks, 2 marks, and even just misplacing one carbon or hydrogen can lose that mark. So you need to understand esters. We need to understand these, how to draw propane, all that type of stuff, the structures. And finally, we need to learn how to do isomers. So in today's video, we will look at the isomers and we will look at the structures. Okay, so we will look at structures, we will look at isomers, and we will look at naming, because naming is one of the most challenging stuff that I've come across. And naming, many people get really confused with naming. So okay, this is just a simple video explaining everything, okay, literally everything. So if you're having difficulties when they tell you to draw a certain type or tell you to name a structure, this video is for you. Okay, if they give you a structure and they say, what is this compound called? Okay, and you're just lost, you don't know, and you just see a lot of weird structures on your screen or your paper, then this video is for you. I know the chemistry exams is coming close, the October-November, hence why I'm just going to go over these small topics, and I'm going to be uploading every single day. So put your notification bells and subscribe to this channel for all the subjects, computer science, chemistry, so on and so forth. So today's video, we're dealing with organic chemistry. Let's not waste any other time, and let's start off with the first one, that is alkanes. So let's talk about alkanes. Now, to draw this alkane, any type of alkane, you will get to know that it ends with A and E. Okay, to end with A and E. So anytime you hear A and E in the end of the word, that is an alkane. Now you need to learn the prefixes of any compound before we even go over how to draw them. We have these following prefixes: meth, eth, prop, but, and pent. These are what you need to know. These are called the basic prefixes. Okay, so these are the basic prefixes. You need to only know the first 5 for IGCSE. So do not learn hexa, hepta, deca, all that. You do not need to know that. You just need to know these 5. Okay, you need to know these 5. So this is very important. This is the first step to understanding this topic. You need to know that these compounds are only within this, okay, and then the different suffixes is how we name these things, okay. But let's first of all talk about the structures. Okay, we look at the naming later. Let's look at the structures. To draw an alkane, okay, you need to understand the fact that all alkanes will have this formula. All alkanes will have this formula. So put this in your heads right here, guys. This is the trick. The trick is to understand this formula. Once when you get that formula down, you will instantly learn how to draw structures. So CnH2n plus 2. We're going to apply this formula to draw any structure. Now, the meaning of methane, meaning of eth, prop, is the number of carbons. Meth has 1 carbon. So if it has 1 carbon, then we will just say 2 times 1 plus 2, CH4. This right here is methane. And that's how you simply make that name. This is methane because it has 1 carbon and 4 hydrogen. Because if I plug in N as 1, then it will give me H4. So that is methane. Okay, I'm hoping you're understanding. I'm hoping you're following up. Okay, so this right here is the main thing that you need to memorize. CnH2n plus 2. So CnH2n plus 2. Let me write this better. And then we will be able to draw any of these structures. Really simple. So let's start off with drawing methane. Let's start off by drawing methane. How do you draw methane? Methane has 1 carbon because it's meth. Okay, methane has 1 carbon. Okay, if it has 1 carbon, what does that mean? That means we said it's going to be CH4. Now, how do I draw this CH4? Let's start off with that. How do I draw this CH4? Okay, I'm going to put a C here and then a H and a H. That's how simple as it is. CH4 is simply like that. And that is how you draw CH4. Okay, let's have a look at the other one. Let's have a look at ethane. Let's have a look at ethane. Okay, actually, let's just draw. Let me structure these notes as like this. So methane is going to be C, H, 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 and H. Let's look at ethane. Ethane has 2 carbons. If it has 2 carbons, I'm going to start off with the carbons, and then I'll surround it with hydrogen hydrogen all around. Then let's start with it. Propane. Propane has 3 carbons. If it has 3 carbons, always start off with the carbons, and then surround with hydrogen. Okay, surround with hydrogen. So methane, propane, methane, ethane, propane. Let's talk about butane. Butane has 4 carbons. And how do I know how many carbons it is? It's because of this. This right here will tell me how many carbons or not it'll have. If it's pentane, it has 5 carbons. If it's methane, it has 1. So this is just the number of carbons. As you go down the group, the carbons increase. Okay? So how do I draw butane? Start off with the carbons. Start off with the carbons. 1 carbon, 2 carbon, 3 carbon, 4 carbon. Surround it by hydrogens. And we've surrounded it by hydrogens. Let's start off with the last one. The last one is pentane. Pentane means 5 carbons. 5 carbons, let's start off with the carbons. And then surround with hydrogens. So we'll surround it with hydrogens. And hydrogens. There you go. So this group, what we have just drawn, is called alkanes. These are alkanes, and that's all you need to know about alkanes. Okay? Simple, right? CHHH. This is the formula that you need to remember. Remember this formula and you'll be good to go. Okay? You remember that formula, and then after that it becomes quite easy, right? That is the alkane group. Let's have a look at the alkene group now. Now, alkene group is a bit different. Okay, the alkene group is slightly different. Alkene. Now the structure for alkene, or the formula for an alkene, is CnH2n. Okay, for alkene it was CnH2n plus 2. Here it's CnH2n. The same structure: meth, eth, prop, bute, and pent. It follows the same structure. All of the functional groups in organic chemistry, or carboxylic acid, alcohol, they all follow this order. 1, 2, 3. This is the number of carbons. It all follows this order. Okay, let's now draw it. Let's draw it. Now the real difference between an alkene and an alkane is that an alkene has double bonds. An alkene has double bonds. So when we are drawing this, you need to keep in mind that alkenes have double bonds. Okay, so if I'm drawing an alkene, and let's for example draw now the reason why methane cannot be an alkene, okay, is because you cannot have a double bond in a methane. You see, the double bond happens with carbon. It happens with carbon. And since methane only has one carbon, you cannot have a double bond. So for alkenes, it has to start with ethene. Okay, none other, because ethene has two carbons. So how do I draw this? To draw this, two carbons, but this will have a double bond. This will have a double bond, and then there will be a H here, H here, H here, and H here. 4 H's. Now what you need to understand is, if I zoom into this, right? If I zoom into this molecule here, okay? This is ethene, right? And if I just quickly show you something, right? Every time the carbon must only can only be surrounded by 4 values, or 4 bonds. Can only be surrounded by 4 bonds. That's why you cannot have a hydrogen, for example, you cannot have a hydrogen here. That will be incorrect. The hydrogen must be here, and let me tell you why. If I use the highlighter here, this is 1 bond, this is 2 bonds, 3 bonds, 4 bonds. Each carbon must have 4 bonds. So the carbon can only have 4 bonds. Okay, the carbon can only have 4 bonds. If I put this hydrogen here, it will become 5 bonds, and we are not allowed to do that. So I'm hoping you've understood that concept right there. Let's draw propene. So propene. So how do you draw propene? Let's start off with the carbons. It always has 3 carbons, and there will be a double bond in any of these. So you can decide to put the double bond here or here, but not both. Okay, we'll come to the naming later, and you'll understand that just in a bit. And then surround yourselves with hydrogens. Okay, surround yourselves with hydrogens. Oops, no, I made, nope. Yeah. We should have how many? So it's going to be C3H6. So we need 3 hydrogens, and we have 3 hydrogens. Good. Now to make this uniform, let me put it up here. So this right here is propene. And if we look at each of them individually again, look at this. 1 bond, 1 bond, 1, 2. So each carbon has 4 bonds. Let's look at this carbon. 1, 2, 3, 4 has 4. This carbon, 1, 2, 3, 4 has 4. So anytime this carbon must have 4 bonds, you need to write this in your notes. That carbon can have only 4 bonds, okay, not 5 bonds. And many people make a mistake. They put this H, for example, here. You cannot do that. So I'm hoping you've got the gist of this. I'm hoping you've got the gist of propenes. Let's look at the last one. Let's look at butene quickly. Let's have a quick look at butene. So butene starts with bute. Bute is 4 carbons. So I'm going to have 4 carbons. Simple. Let's go with the hydrogens. Hydrogen. Okay, no. Let's look at with a double bond next. The double bond, we can put it here Then let's do the hydrogens. So hydrogen, 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 and butene is C4, so H8. So 8 hydrogens. So it'll be a hydrogen here, a hydrogen here, and hydrogen here. Okay, so there you go. That is 8 hydrogens, if I'm not wrong. 1, 2, 3, 4, 5, 6, 7, 8. Nice. That's 8 hydrogens. So this right here is butene. Every carbon only has 4 bonds, and we can see this. We cannot put this hydrogen here. It will be incorrect. I'm going to keep reminding you that. So that is how you draw it. Now, let's look at naming. Let's look at naming. Right now, what we just drew was called butene. Okay, but what if I make this double bond, instead of here, I take it here. Okay, so let's erase this. What happens now? How do I call this molecule? Because it changes, the name changes, and the new name will become 2-butene. And this is because this 2 represents where the double bond is, where the double bond is. But one might argue, if I put it here, does that become 3? No, because you must count from where there's the least. So if I put it here, right, if I put it here, then that means I'll have to count from the right side. So from here, that is still the second position. So wherever it is the shortest is where I'll put it. Let's explain that again with another type of example. Let's draw pentene. And I'm going to explain it with this. I'm hoping you're going to understand this way. If you don't understand, don't worry. Right now, you will just understand in a second. Pentene has how many carbons? 5 carbons. Let's draw the double bond here. So hydrogen, 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 hydrogen. So this pentene will be C5H10. Hydrogen, 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 hydrogen. 10. Okay. Now, let's understand naming here. Okay. Now is when you're going to understand naming. Right now, so we're going to say position 1. Okay, we're going to call it position 1. This is position 1. Okay, let's do it with another color. So this is position 1. At position 1, the name of this compound is simply pentene. Okay, at position 1, the thing is called pentene. What about position 2? Let's have a look at position 2. At position 2, I'm going to take this double bond and I'm going to put it right here. At position 2, it becomes 2-pentene. It becomes 2-pentene. And remember 2 because it is in the second place. Okay, this is the first place, this is the second place. This is the first place, this is the second place. This is the third place, fourth place, so on and so forth. Now let's move this double bond to the next position. Let's put it here. Now at position 3, it becomes 3-pentene. Why is that? 1, 2, the first carbon, first year, second year, and third year. That's why it's called 3-pentene. But now, if I move this to the next one, it will not become 4-pentene. It will become 2-pentene. Because I must always pick the side that is least carbon chain. So this is the most least. So I will now go from right to left. Because I have to always pick the side with the fewest carbons. Okay? And that is the reason why. So I've explained naming right here in a quick way. And I'm hoping you have understood this. Okay? I'm hoping you have understood this concept right now. Okay? I'm hoping you've understood this concept and you've got it. That is naming. And we're going to finish alkenes there. Let's go to the next functional group. I'm hoping you've understood. Let's go to the next one. Let's go to carboxylic acid. Okay, I don't know if I've spelled that right. Let me go check up. Carbox and then YLIC. Okay, so there is no C again. Carboxylic acids. Now, for carboxylic acids, okay, it's simply in the end, the last carbon just has this and then this. This is the group. This is a carboxylic acid. So if I have methane, and I want to make it an carboxylic acid, I will draw meth with one carbon, but instead it will become like this. Okay, it will become like this. So this will become like this, and the formula for this will be CnH2n O2 and H. O2 and H. Or some people write it as 2n plus 1. Let me show you. Some people write it as 2n plus 1 O2. This is the formula. So let's draw let's draw this actually. Let's draw ethanoic acid. Ethanoic acid. Let's draw ethanoic acid. Ethanoic acid. So we're going to start off with 2 carbons. The last carbon is going to have O and then OH. Actually, let's put a O and then H. And the other carbons just have hydrogens around it. Okay? That's how you do it. Simple. No double bonds, nothing like that. This is how you draw it. Let's draw propanoic acid. Let's draw propanoic acid. Propanoic acid, 3 carbons. Okay, last carbon, we do O and then like this. This is the group. For the last carbon, just follow that. And then the rest just have hydrogens. Okay, the last just have hydrogens. Okay, look, it agrees with the formula. C2H5O2. Does that agree with it? Yes, it does agree with it. This is the formula. Okay, so that marks the end of the carboxylic acids. Okay, let's have a look at alcohols. Now you see it becomes quite easy, and there's no bonding, so the names won't change. And the same now, let's go for alcohols. Now let's look at alcohols. So alcohols, let's draw methanol. Let's draw methanol. To draw methanol, simply just do OH instead in the end. Simply just have to do that. This is methanol. So instead of, in alkanes we had a H here, instead of this you remove it and it becomes CH, it becomes OH. So this is an OH. Okay, this becomes an OH bond. Okay, an OH group. And what is the formula for methanol? Is there any particular formula? CnH2nO. That is how you could write it. Or, yeah, I think that agrees, right? No, sorry. It will not agree. Yeah, it will agree. Sorry, no, it won't. Okay, let's see. So C, if I have 1 carbon, I should have 4. Yeah, it's like this. So if I have 2 carbons, there's no actually formula for this. There could be, but coming to my mind, there's no. So if I want to draw ethanoic acid, ethanol. If I want to draw ethanol, so we're going to have 2 carbons because it's eth, H, lost. I just add an OH here, and the rest just fill it with H's. Yeah, with H's. So this right here is C2H5O. So I think it's the same formula, CH2n plus 1O. That's the formula if I'm right. But let's draw butanol. So actually let's draw propanol. It's gonna be easier. Propanol. If we draw propanol, prop has 3, and then the rest is hydrogen here. We just add OH. There you go. So here the formula will be C3H8. So you can see, I think the formula is varying from time to time. Yeah, so there's no formula, I guess. Yeah, so it's changing. Okay. Right, so this is propanol. Okay, so this is propanol. So I'm hoping that marks the end of this video. Let's have a quick recap here. You need to memorize this: meth, eth, prop, but, and pent. Then for alkanes, they follow this structure: CnH2n plus 2. Let me write that better. For alkenes, they follow a simple CnH2n, and then naming done according to where double bond. Okay, and next thing you need to know, count from shortest carbon length. Then we have the carboxylic acids and we have the alcohols. So right, that marks the end of structures of organic chemistry. There's a lot in organic chemistry that you still need to know. For the notes, I want you to go over the Google Notes, many other types of notes people have uploaded, and you are supposed to cram all the factors of for example, of alkanes, of alkenes, of carboxylic acids, of alcohols. You need to cram each one of them. Okay, you need to cram each one of them. That I can't help. You have to just go over all the notes, go over your textbook. For the structures, I'm hoping this has helped. We still have another topic called esters, and then we have also polymers, which is another topic of organic chemistry. So I'm hoping that you have now learned how to draw them at least. I'm hoping at least the one thing that you need to take from this video is how to draw the different structures. So how to draw methane, how to draw ethane, how to draw propane, ethene, methane, all that, and how to at least name the alkenes. Okay, at least name the alkenes according to where the bond is placed. Okay, so that marks the end of today's video. I'm hoping this has helped you with your revision with organic chemistry and also with the revision for your exams. So thank you guys for watching this video, and I'll see you in the next video.